We're going to talk about Section 1 in Chapter 1 of Statistics and Behavioral Sciences. Statistics serve two general purposes. First off, they are used to organize and summarize information so researchers can see what happened in the study and can communicate the results to others. Secondly, statistics help the researcher to answer the questions that initiated the research by determining exactly what general conclusions are justified based on the specific results that were obtained. What is statistics? It's a set of mathematical procedures for organizing, summarizing, and interpreting information. Statistics help researchers bring order out of chaos. Statistics provide researchers with a set of standardized techniques, which you are going to learn about in chapters 8 and on, that are recognized and understood throughout the scientific community. Statistical methods used by one researcher will be familiar to all other researchers, so they can accurately interpret the statistical analysis with a full understanding of how it was done and what the results signify. Let's look at statistics in the housing market. For example, you might look at the average price of a house in a neighborhood to make sure you're not going to pay too much. You might look at crime rates. You might look at school information. Will your children have a good school to go to if you move into this neighborhood? Statistics in sports. You might think of runs batted in, the average free throws in basketball. Politics. You might look at polls. Education, you might look at a particular test that you've given or taken in a classroom, the mean or the average of the test. You might also look globally at like ACT scores or SAT scores. You might look at college entrance statistics. Each school admits a certain proportion of students each year. Let's talk about a population. What is a population? It's the set of all the individuals of interest in a particular study. And here's an example of a statistical study. A researcher may want to know what factors are associated with academic dishonesty among college students. The population that they're looking at is all college students. Here's a second example. A researcher may want to determine the effect of lead exposure on the development of emotional problems in school-aged children. Again, the population here would be all school-aged children exposed to lead. Now let's talk about a sample. A sample is a set of individuals that you select from the population, usually intended to represent the population in a research study. Samples are important because we can't always ask every single person in a population. You can't ask every single college student across the U.S., but you could choose a sample. In a random sample, everyone in the population has an equal chance of being selected as part of the sample. Here's some examples of statistical studies. A researcher may want to know what factors are associated with academic dishonesty among college students. We talked about this a minute ago. The population is all college students. The sample might be 100 college students that you use in your study. Let's look at the second example that we talked about. Again, the population for this was all school-aged children exposed to lead. You can't possibly talk to all of those students, so you choose a sample. Here, 25 school-aged children exposed to lead would be a good sample in order to do research. Let's talk about generalizing the results. First off, the population is all the individuals of interest. Say, for example, all the college students in the U.S. Then you select a sample. Okay, I want to select 100 college students from my local university. Well, maybe the first 100 I contact, some will agree to be in, some won't. Eventually, I'll find 100 students that will. And that's at the bottom of my circle here. That's the sample, the individuals that actually selected and want to participate in the research study. Finally, the results from the sample are generalized to the population. So to answer a question, a researcher studies a sample, and then they generalize the results from the sample to the population. Let's talk about data. Data is plural. Data is measurements or observations. You can collect data by measuring your score on a test. You can also collect data such as how many times did a child seem off task in a 15-minute period. Those are both data. A data set is a collection of measures or observations. A datum is a singular measurement or observation, and in statistics, we most commonly call this a score or a raw score. Research typically involves measuring each individual to obtain a score. What's a variable? A variable is a characteristic or condition that changes or has different values for different individuals. Example, does weather influence online ratings of restaurants? Or in other words, as the weather changes, do people's reviews of restaurants change too? Well, the variables here, we would be looking at weather, because the weather would be changing, right? And we would be looking at people's reviews. People's reviews would be different for different individuals. So those are two variables for this study. And the outcome in this study was that reviews were worse during bad weather. So weather influences how good or bad you thought a restaurant was. All right, statistics are useful in the understanding of what kind of data needs to be collected, how much data is needed to provide sufficient guidance. For example, if you were going to poll some people to see who you thought was going to be president, you wouldn't just poll 10 people. The results of that would not provide guidance for us to see who was going to be president. You would have to poll several thousand people or more. How should data be organized? And finally, how can data be analyzed to draw conclusions? Let's look at a parameter versus a statistic. A parameter is a value, usually a numerical value, that describes the population. Parameter is usually derived from measurements of all the individuals in a population. An example of a parameter would be the average ACT score of every person in the U.S. who has taken the ACT. A statistic usually describes the sample. The statistic is derived from measurements of the individuals in the sample taken from a population. For an example, the average ACT score of 100 students at MSU would be a statistic. The average ACT score of every person in the U.S., again, would be a parameter because you're talking about every person in the population. So when you take an average or from a population, it's a parameter. When you take an average of a sample of people, that is called a statistic. Let's look at the difference between descriptive statistics and inferential statistics. Descriptive statistics describe, summarize, organize, and simplify data. An example of this might be the mean of a classroom, all the scores together into a mean, a standard deviation, a variance. Inferential statistics use those sample statistics to generalize or make inferences about the population of interest. Example, you might compare scores of two different classrooms taught by different methods and interpret the results. Let's look at sampling error. Sampling error is the naturally occurring discrepancy or error that exists between a sample statistic and the population parameter. So example, the population mean of the math SAT subtest is 500. This takes into account every single person who has taken this test. Suppose that a sample of 100 students who have taken the SAT have a math subtest mean of 515. So the population mean, which is called a parameter, is 500. The sample mean, which is called a statistic, is 515. There's a 15-point difference between the sample statistic and the population parameter, and this difference is called sampling error. Example 2. Candace Brown leads the poll with 51% of the vote. Candidate Jones has 42% approval, and the remaining 7% are undecided. The poll was taken from a sample of registered voters and has a margin of error of plus or minus 4 percentage points. Here's another sampling error demonstration. If you wanted to look at this one, there's 1,000 college students in the original sample, and there's 5 students chosen to be in sample 1 and 5 in sample 2. You'll notice that their sample statistics are a little bit different than the population parameters in each case. The differences, again, would be sampling error. Here's another example, college students. Sample A, you have 15 students who read their material from printed pages. Sample B reads their material from a computer screen. And then you give them a quiz or a test. The average score for sample A is 26. The average score for sample B is 22. And then you interpret those results. You need to notice that there's a 4-point average difference between 26 and 22 as the average. So you have to decide, is there really no difference and really it's just sampling error, or there really is a difference and the data do reflect this. Learning checks are for you to try to do the material and then go through and see the answers. You can pause the video while you work the problems. For this question, you'll notice that when you're talking about the population of students and then you talk about a sample, again, there's sampling error. So the sample probably would still have an average around 500, but it's probably not exactly equal to 500 because of error. Here's 3 more questions for you to practice on. Pause, and when you're finished, go ahead and click continue, and it will show you the answers.